Welcome back, Solidity developers. This is Tenna. Today we're going to take a look at proxies on the Ethereum blockchain network and how we can utilize them to do really cool things. I'll try to put timestamps on this video so you can skip over certain parts of the video if you already know things that I'm going to explain. Otherwise, I hope you guys enjoyed this video. Thanks for tuning in. So let's go ahead and create a simple example of a beacon proxy. So for example, let's imagine a shipyard. Let's create a factory that's going to manufacture these ships based on a certain blueprint that we are going to give it. Now, this blueprint can update anytime. This is because we want to be able to upgrade our ship as needed in the future. Once the blueprint of the ship is determined, we're going to direct the beacon proxy to point to this new implementation or blueprint that we want our factory to utilize when creating the future ships. Also, because already deployed ships refer to the beacon proxy to get their implementation or blueprint, they will also receive the update, and all we have to do is update it in one spot. So let's go ahead and take a look at how we can actually do this. Today I'm going to keep it simple and use Remix to create this because it's not going to be a big project. However, it's going to be really powerful. So let's go ahead and start by creating the ship implementation. So let's make this weird. Okay. So ship.sol is the name of our smart contract. Let's go ahead and use latest version of Solidity. So for this ship, we're going to import a few things from OppenZeppelin. We're going to use the initializable, which is going to allow us to do this really cool thing I'm going to explain. So let's go ahead and create the smart contract. Let's call it ship, and let's make it is initializable, and let's go ahead and give it a name because we want to have a name. We'll make it public so we can easily call it later. And then let's use a uint256 to keep track of its fuel. So the first thing we want to do is write a function called initialize. I think I spelled it right. Nope, I did not. So this function is actually going to be what's called by the factory that we're going to make in a moment. That's going to initialize the ship. So if you're thinking, hey, that sounds like a constructor, yes, it's exactly like a constructor. But because constructors cannot be called because they technically don't have a name, you have to write a function called initialize, and this function is going to be able to be called by name by another smart contract, which in our case is the ship factory. It can take in arguments just like the constructor and set your initial arguments. So let's go ahead and do that. Let's take in a string memory. Let's call it underscore name. It's going to be what the ship factory is going to give us a name. And then let's say uint256. This is going to be fuel. And this is going to be our gas tank, or how much fuel that we're going to give it. And then that's all we need. And this is going to be an internal function. And then we want to make sure that we include the modifier initializer. Essentially what that modifier is going to put in is a few safeguards. For example, make sure that only owners can call this function, as well as if it's already been initialized, it can't be reinitialized, because you can see the danger here with using this function. It can be called over and over and over again to change the name of your fuel, or the name of your ship, and the name and the fuel amount. So in order to prevent that initializer function, which is inherited from the initializable library from OppenZeppelin, is going to allow us to put those safeguards in place. So let's go ahead and assign the values respectively. Now that we assigned a name and fuel amount for the ship once it's initialized, let's go ahead and create a function. Let's call it move. Make it a public function so people can access it and move our ship. And let's require, actually we're not going to require anything. Yes, we're going to require that we have gas in our tank, because that only makes sense. So fuel has to be greater than 0. Otherwise, no gas, or let's say fuel, so we don't get confused with Ethereum gas or gas fees. So after we have verified there's enough gas, let's just say a move is just gonna take away some gas and not really do anything else. My dog just said, because apparently I cannot spell today. I've been spelling it wrong this whole time, right? I had to Google it. Wow, alright, there you go. Alright, so we just created a ship that is initializable. And it is initializable using the function called initialize. It takes in 2 arguments. One is a name, one is a fuel amount, and then it's gonna assign those values to the name and fuel variables we have defined within the ship respectively. And once we have that, our users can go ahead and call the function move that will allow them to move. And in our case, it's really not moving, it's just taking 1 away from the fuel, and that's what we're doing right here, fuel minus minus. Pretty simple, straightforward. I can actually deploy it right now, and you'll see that as you can see, we don't have a constructor right here. So as you can see, because we don't have a constructor, it's not requiring us to enter any arguments before we deploy. We can just deploy it without any arguments, and as you can see, once it's deployed, clicking fuel and name will return nothing because we haven't really called the initialize function yet. So one thing I realized is that the initialize function needs to be external. So let's go ahead and deploy that. And as you can see, we have all of our functions as well as our variables. So right now, because we just deployed it and we didn't call the initialize function, there's not going to be a name or a fuel amount assigned to this ship instance. So yeah, we've successfully built a ship, and let's build our factory next. So let's go ahead and create a new file. Looks like there's a lot going on here. So let's just create a new file right after ship.sol. Let's call it ship factory.sol. Same thing, pragma. So let's go ahead and import the OppenZeppelin beacon proxy library. And then let's go ahead and import the upgradable beacon library. Let's start by writing out our ship factory smart contract. Sorry about my dog. So now that we have the skeleton of our ship factory and we have the necessities imported, let's create the beacon. So again, we have a ship factory, which makes the ships. We have the ship blueprint, and then we have the beacon that's gonna allow us to always know what the current blueprint is that we are using. So let's go ahead and create that beacon. So let's go ahead and make a new file. Let's call it ship beacon.sol. Same thing. Actually, I'm gonna copy and paste because I'm lazy. Let's change the contract name to ship beacon. The imports, let's keep them. Actually, let's get rid of the beacon proxy. And then let's import the ownable functionalities from the OppenZeppelin library. And then we want to go ahead and inherit the ownable library by just saying ship beacon is ownable when we declare the contract. So the first thing we want to do is we want to make a variable that is going to hold our upgradable beacon. So just like how we declare string or uint, we're just saying this is type upgradable beacon, and that's getting it from the OppenZeppelin library. Let's give it a name. Let's call it beacon. And then one thing we want to do is we want to make it immutable. So you do that right before the name declaration. That's just going to say that, hey, whatever I initialized during the constructor, don't ever change it. So this will be the same billboard that we use over and over again. However, what values we store in it, we can change by writing functions. So let's go ahead and write a constructor. Let's actually make one more variable. This is going to be type address. Let's make it public so we can easily access it. And then let's make it implement. Actually, let's make it blueprint so we can stay consistent with our story. So the first thing we want to do is make a constructor that takes an address, and let's call it initialize. Let's call it init blueprint. So what this constructor is going to do is going to take the beacon that we just declared on line 10, and we're going to initialize an actual instance of an upgradable beacon. And when you want to create a new instance of upgradable beacon, you have to use its constructor function. So if we actually look at the documentation on OppenZeppelin, you can see that the constructor for the upgradable beacon smart contract, it just takes in one value, and that's implementation, and it tells you that it's going to set the address of the initial implementation, or in our case the initial blueprint. So that's why we want to pass it an address of the initial blueprint. So let's go ahead and copy and paste that. So that's what that's looking like. Then after that, we want to set the blueprint address variable that we have declared earlier right here on line 12. So then from there, we're going to want to transfer ownership, and we do this by using a function that we inherit from the ownable library called transfer ownership. And it takes in the new owner that you want this smart contract to have. And for this, we're not going to do message.sender, which is typical, but we're going to do tx.origin, which essentially is going to mean take the very first person that initialized or initiated the transaction. And you'll see why this is needed in a little bit, because the ship beacon is actually not going to be directly called or made or constructed by a user. It's actually going to be constructed by the ship factory. However, by doing that, if we do message.sender, it's going to inherit the address of the ship factory and say that's who owns it. However, in our case, we want to make sure that we still, by we mean the deployers of the ship factory, have that ownership. And I'll show you what that means in a little bit if that confused you. So our next function is going to be the upgrade function. So this upgrade function is going to be responsible for updating the implementation or the blueprint that this beacon is putting out to the world. So let's just make it update, and it's going to take an address, and it's just going to say new implementation. And this is going to be a public function, accessible only to the owner, so let's add that modifier. And again, this is coming directly from the OppenZeppelin ownable that we just imported, so we don't have to declare it anywhere else. That's why I really like OppenZeppelin. Owner, can't spell. Okay. So within this upgrade function, all we got to do is get the beacon, right? The beacon that we declared right here on line 10. We're going to call a function within it called upgrade2. So looking at the documentation is where it's really helpful to look at the documentation. You'll see that upgrade beacon smart contract, which we imported right here, has three functions. One is the constructor we just utilized to set the initial implementation or blueprint. Second one is called implementation, which just returns the implementation, the current implementation. And then the third one is upgrade2, which is going to be responsible. If you click on it, it's going to tell you responsible to update the implementation. And you'll see that message.sender must be the owner of the contract, and the new implementation that we pass in must be the address to the new contract. Let's go ahead and call that, and we do this by saying beacon, because we already declared it right here and initialized it right here. So we can say beacon.upgrade2 and then pass in the new implementation address, which we got from the user. And let's change this to blueprint so we stay consistent instead of new implementation. And then blueprint equals new blueprint. And that's just storing, it's just updating in our local right here. Whereas this upgrade2 is actually updating the instance of our upgradable beacon, which we created on line 15, which is another smart contract that lives at a different address. So those values, and you can see those values right here in the documentation, those values and those functions within it, you'll see are stored all right here. So we have to call, that's why we're calling upgrade2, and then we're giving it that new, and then it does its thing and updates its internal pointer to the blueprint. And then right here, we're just updating our ship beacons internal. So up next is finishing up the ship factory. So let's go back to the ship factory and let's import the ship beacon, because we'll need that we'll need to know what blueprint that we're going to be working with. And then let's keep the two imports, beacon proxy and upgradable beacon. Actually, we don't need upgradable beacon. All right, so within our ship factory, to make our lives easier, let's create a mapping that is responsible for keeping track of all of the ships that the ship factory creates. So it's going to be a mapping, a number to an address. So every time we deploy a ship, it's going to give us an address, and we're just going to assign that address a number. So then later it's easier for us to just say, all right, what's the address of ship 1? Up next, let's make a variable that's going to hold our ship beacon. Let's make it immutable because it's never going to change. We're always going to refer to the same beacon, and that beacon is the ship beacon we just created right here. We just created it right here. We're going to import it on line 5, and then we're going to go ahead and give it a variable name so we can use it later. And then it's going to allow us to call these functions. So I'll show you in a little bit. Giving us an error. It's saying that we need to initialize this immutable variable. So in order to initialize that, we're going to use a constructor function. So this is going to take an address. Let's call it initial blueprint. So whoever deploys this ship factory is going to have to provide an initial blueprint to the factory so that the factory knows what type of ship it's going to make. So with that being said, yes, we do need to deploy the ship out to the test network or main network or whatever, and grab its address, and then provide the address to the constructor of our ship factory, and then we can continue. So I'll show you that in a little bit. But once we get that initial blueprint address given to us, we're gonna go ahead and say beacon, which we just declared or created on line 11. It's just gonna equal new ship beacon, and it's gonna take address that we just passed it in. So again, we're saying that on line 11, beacon is gonna be a variable that's gonna hold a smart contract of type ship beacon, and we imported that, which we just created. The constructor function requires that we pass it in an address of the blueprint. So that's what we're doing right here. We're saying create a new ship beacon, and that's just essentially calling the constructor, and we're giving it an address, and then we're going to assign that instance to the beacon variable so we can go ahead and use it later. Hopefully that made sense. So that's all our constructor is doing. Pretty simple, straightforward. Next function we're going to write is build ship, which is the main function of our ship factory. So to build a ship, we'll need to know a few things, right? So let's go back to our ship blueprint and let's see what our initialize, which is the constructor, quote unquote, for this ship. Because we are treating this as a blueprint, we're not going to want to have a constructor because we can't call that in the ship factory, which I'll show you in a little bit. So anyways, let's look at the initialize function and what it takes. It takes in a string called name and a number called fuel. So that being said, we'll need to know the name and the fuel that we want in our ship. So let's go ahead and say string memory, and let's say name, and then second variable, let's call it UN256, and this is just going to be underscore fuel. Hopefully I spelled fuel right this time. So now once we have that, all we have to do is create an instance of a proxy, right? So if you look back right here, what we have so far is this doesn't have the factory, so don't get it a little too confused, but what we just created is the beacon right here, the beacon, which again is going to hold the implementation address. So if you look at the code right here, ship beacon has the blueprint right here. So all it's doing, it's holding the address of our blueprint, and then that's the beacon. And then our implementation, aka the blueprint itself, is the ship. And you see how we referred to it. We said, oh, what does this ship need to be built? That's the name, the fuel. That's us referring to the blueprint. And that's what's, this is upgradable, right? You can add functions to that, and I'll show you that in a little bit. And then that's the implementation. and then now it's the proxy, right? So what we're doing right now, and then in our case, we have a factory right here. Pretend like there's a factory right here where it says call foo. That is essentially gonna make all these proxies for us, because each instance of a ship essentially is a proxy that is able to get implementation from the beacon, and then once it gets that implementation, it's able to execute functions based on that implementation, or delegate the calls to the implementation blueprint that we are currently working with. So again, it doesn't have a factory on this diagram, but ships are proxies. Like you have multiple proxies or multiple ships pointing to a beacon to get the implementation that they are, and then from there, whatever calls that come in will be routed to that implementation or blueprint to get called. So hopefully that didn't go over to your head too much. I'll link this as well as the documentation in the description so you can read it, but that's where we're at right now. So back to where I left off here. So and essentially what that was trying to prime you for is what we're gonna do right here. So let's make a beacon proxy, and I just realized that, yep, so let's make a beacon proxy variable, and let's call it ship, because essentially that's what the proxy is gonna represent. It's a ship. So let's say new and then beacon proxy, and beacon proxy again is another smart contract that we just imported, which has a constructor that takes in a beacon and then a data. So if you look at this right here, when we're creating this proxy, it's gonna have to know what beacon to look at. So that's why we give it in the first argument. And then the data is what function do you wanna call to initialize that beacon. So in our case, we wanna call the initialize, right? So that's gonna be in the form of bytes data, and I'll show you how to encode a function call to bytes data, essentially encoding the calling of this initialize function into just bytes data that you can pass as a variable into this constructor of the beacon proxy. So let's go ahead and create that beacon proxy. It's going to take a beacon, which we have right here. So that's why we gave our ship beacon a name right here, and then initialized it so we can be able to do this and use it. That's the first variable. And then the second variable is the call data. So now this is where it gets a little confusing, so bear with me. I'm gonna make a new line so we can keep it clean. So what we want to do is say ABI dot encode with the selector, or encode with selector, sorry. So what this is allowing us to do is it's gonna call a function from ship, which is going to be deployed at address 0, and the function that we want is dot initialize and dot selector, and then we're going to input the variables that we want to pass to the initializer function. I think that's my dog drinking water. So that's that. It's giving us an error saying we have to declare if it's public. Let's call it public. And then here, ship, oh, we need to import the ship so it knows what the ship is, you know, what ship we're referring to. Oh, underscore fuel. Okay, cool. Oh, we have one more error. Oh, this is not owner. We don't need an owner. Sorry to confuse. I was looking at my notes and I had a different implementation. Anyways, let's see. Last error. Initialize. Am I spelling the function name incorrectly? Initialize. Yes, I did. Okay. There we go. All these errors. Oh, I got you. So what we did is we passed it the beacon, the ship beacon itself. What it's waiting for is the address of the beacon. So let's enclose that in parentheses, and then let's just cast that to the beacon address. Oh, I need to say new beacon proxy. Okay, sorry to confuse you. So we just created an instance of beacon proxy, which you can look at the documentation for. This is coming directly from OppenZeppelin. What we're gonna do here, we're just creating a proxy, or in our other words, a ship that knows of a beacon right here. And because it knows of that beacon, it knows of the current blueprint. Because it knows of the current blueprint, any call that comes through it will be executed according to that blueprint. That's what we just created here. So we have a ship, and what we want to do to this ship is we're actually going to add one more argument to the parameter list, and it's going to be type 256. It's going to be uint 256, and let's call it ship ID. Every time they want to create a ship, it's just going to be a normal number, and it's going to be used to map a number to every ship that was created. We can easily look it up later. Let's go ahead and save. Let's see what's given us. Ship ID. Oh, this needs to be uint 32. So just to recap, we have a ship factory that knows of a ship beacon that knows of a ship implementation or blueprint. And because they all know each other, we can do this. So let's go ahead and, again, let's clear up our workspace, delete any smart contracts that you have. First things first, we need to deploy a ship to use it as a blueprint. So let's go ahead and choose ship, and again, I'm using the JavaScript VM. You can use Ganache or whatever testnet should work. So let's hit deploy. It's going to deploy, it's giving us a ship here, and we can get the address that it lives at. Let's go ahead and select ship factory and paste the address, and we have a ship factory and it has a beacon. Let's get that loaded up, and we're only loading up the beacon so we can upgrade what we're pointing to. So let's go ahead and not deploy again. Remember, we're just loading it at the address that it was already deployed at. And by doing that, it allows us to access the functions. So now what we can do is try to create a ship, call it Tenna, ship ID 1, and let's give it a fuel of 10. Transact. Looks like it went through. And because we gave it ship ID 1, we can get ship address by typing ID 1 right here. It's going to give us an address. And then we can load that in Remix by going to contract, selecting ship, and then typing in or pasting in that address that we just got from our factory. And we pulled it up, and we'll see that this is the ship that we just deployed. Click on the name, it says Tenna. Fuel, spelled fuel wrong I think, but you know that it has 10 because that's what we just gave it. Owner, I don't think we set that up yet, but that's for another time. Anyways, we have that ship, right? Cool. Let's call move on it, and remember, move just takes away 1 from the fuel. Let's do that, keep doing that, keep doing that. We have 3 fuel left, keep doing that, keep doing that. As you can see, it says no more fuel. We ran out of fuel. Well, it would have probably been smart to have a function called refuel on the initial implementation, but we don't. But it's okay. We can upgrade our beacon to point to a new implementation of our ship. So how do we do that? Well, first we have to follow a few rules. 1, whatever new ship that we make, it has to have the same variables declared in the same order. So right here we declare string public name, uint public fuel, so on and so forth. Everything stays the same. The only thing you're able to change is the functions, right? So we can add or get rid of functions. I'm not sure if we can get rid of functions. I think we can, but let's just go with only append. So we can upgrade this smart contract. We would just have to copy this code as is. Let's make a new, let's call it ship v2.sol, and let's paste it. Right, everything is the same. However, what we want to do is we want to upgrade it by adding a new function right after move. Right, we don't want to switch these around because this will ruin the data of the ships that are already deployed. You can read more about it in the in this documentation that I will have in the description. Anyways, let's write a function called refuel, and it's gonna take it's not going to take anything. It is going to be public, and it's not going to return anything. So let's just say fuel plus plus. Right, we're just adding one to the fuel. Cool, got it. And let's change the contract name to V2 so we can distinguish it better. Let's go ahead and save. Okay, cool. So again, just like how we had to deploy that initial blueprint of our initial ship right here, the first deployment, we have to do the same thing with ship V2 just to deploy it so we can get an address. Copy that address, and what we're gonna do is we're gonna open up our beacon, ship beacon, which again is already deployed by the ship factory, and you can see where that beacon lives and load it using the remix interface. So that's what I got going on right here, and you can see that get implementation, sorry, my dogs are playing. Get implementation currently points to the old ship right here, which is the first blueprint we deployed. We don't want that because that doesn't have the refuel function. So what we want to do is we want to call the upgrade function, and we want to pass in the new ship v2 address, and then we call upgrade. Looks like it went through, and we'll click get implementation, and it updated to point to the new ship. So what does that mean for us? Well, all future ships that we create using the ship factory, we're gonna use the newly ship v2 blueprint, and that's already done in the back end for us. And what does that mean for the ships that are already deployed? Well, let's say this ship, for example, the one with the name Tenna, well, it still lives at that address. Nothing has changed with that. But the thing is, because it's pointing to the beacon, which is pointing to an implementation, we just updated the implementation or blueprint that the ship beacon points to, that inherently means that the ship now knows of this new implementation. So how do we test it out? Well, as you can see, it doesn't have a button for refuel, and that's just because Remix only loaded the ship, the original ship's functions. However, let's load the same contract at the same address. Let's copy that address. Let's go ahead and load it at address. However, this time we're not going to select ship 1, we're going to select the ship v2. So load it, same address we're pointing to. So the ship itself never changed, it's the same ship. However, we're just putting in an interface, a UI, so we can get the new button refuel. And this is all because Remix gets these buttons based off the functions, and the first ship did not have the refuel function, so therefore it doesn't have a button. But in the back end though, because we pointed the new implementation which has this refuel, the back end has it. We're just doing this so we can be able to actually click a button and refill. So let's go ahead and see if this works out. So first of all, let me prove a point to you. This is the same ship because it has the same name, same ship because remember last time we checked, we ran out of fuel and we can't move anymore. Again, no more fuel. However, because we have this new upgrade, we can refuel, and you can see that we have one more fuel. We can move again, going back right back to 0. We can keep refueling. Now we have 6 fuels, same name, same fuel, same gas tank, just new implementation. So again, in the future, if you're trying to upgrade your ship, all you have to do is make sure you append only. You don't delete, you append. And then once you're done, you deploy that ship to a new address, which you'll use that as a blueprint, and get that address and upgrade your beacon using the upgrade function we built, which updates the factory, which ensures that every newly created ship is going to take on the latest blueprint, and it's going to also update the already deployed ships so they have the latest update. And that's it for upgradable beacon proxies. I know it was a lot in one video, so you're probably gonna have a lot of questions, so please feel free to drop a comment down below and I'll try to get back to you as quick as possible. Again, I'll have the code posted up on GitHub so you can take a look at it without all the bugs that come along with coding live. Otherwise, thank you for tuning in to Tenna Codes. Like this video if it helps you in any way. Drop a comment with questions or any remarks. Make sure you also subscribe so you are notified of new videos. Well, that won't happen until you click that notification bell. So subscribe and click the notification bell, and let's build this community up, y'all. Thanks for tuning in.